All right, let's dive right into this explainer. Today, we're looking at the absolute fastest, most strategic way to secure clean, firm energy from massive data centers. We're breaking down a highly specific virtual power plant proposal that's designed to solve one of the most pressing infrastructure hurdles we face right now. So here's the fundamental infrastructure puzzle facing Alphabet and Google executives today as these new hyperscale facilities come online. How exactly do you deploy massive compute power without causing immense grid friction, triggering a regulatory backlash, or spiking utility rates for everyday folks? We've structured this explainer into 5 quick areas. First, the AI energy bottleneck. Second, the edge control paradigm. Third, the 15 megawatt pilot blueprint. Fourth, Google's strategic triple stack. And finally, a globally scalable model. Part 1. The AI energy bottleneck. Let's talk about the sheer power draw of AI, specifically when you look at massive adaptive reuse projects, like the Alcoa Tech Center corridor. You're talking about a facility slated for a massive 280 megawatt bulk utility tie-in. A concentrated demand shock like that literally threatens to overload local substations and severely strain the entire regional grid. And this perfectly illustrates the immediate problem with the old way of doing things. Honestly, relying on centralized natural gas peaker plants, it's a failing strategy. Global supply chain constraints have pushed turbine delays out to 4 to 7 years, and costs are hitting 10-year highs. We're talking up to $2,000 per kilowatt. Plus, relying on centralized generation leaves us incredibly vulnerable to devastating climate-driven weather shocks that ripple through the economy. On the flip side, renewables paired with battery storage actually reduce overall utility rates. They are practically instant to deploy, they're the absolute cheapest power generation available in the US today, and, this is key, they require absolutely zero subsidies to be effective. Moving to Section 2, the edge control paradigm. To solve this modern bottleneck, we actually have a historical blueprint right here from Pennsylvania's Turtle Creek Valley. Back in the late 19th century, George Westinghouse tamed the violent, high-pressure natural gas roarer and early AC electricity by realizing one fundamental truth: centralized volatility absolutely must be managed by decentralized edge regulation. You contain the immense pressure at the source, right? And then you use a step-down transformer at the edge of the network to deliver safe, usable power locally. It was an elegant solution, and it quite literally changed the world. Fast forward to today, and we see the exact same logic, the modern equivalent. The home hybrid bidirectional inverter paired with battery storage acts as our new transformer. It sits right at the edge of the grid at the home and completely shields the local substation from those massive data center shocks. It instantly translates residential power reserves into synchronized, localized grid stabilization. Part 3. The 15 megawatt pilot blueprint. We aren't just talking theory here. The exact mathematical blueprint for an initial statewide consumer edge dispatch pilot in Pennsylvania is rock solid. Just look at this 4-hour smooth dispatch matrix. It proves that by dynamically balancing fading late afternoon solar with a standard 10 kilowatt-hour home battery, we can guarantee a flat 2.5 kilowatt injection per home during those absolutely critical peak hours. For example, during Phase A, from 4 p.m. to 6 p.m., the home balances 1 kilowatt of solar and 1.5 kilowatts of battery discharge. Then, as the sun sets in Phase B, from 6 p.m. to 8 p.m., it shifts entirely to 2.5 kilowatts of battery power. And the best part? A single household only uses 8 kilowatt-hours total. That means we never drop below a 20% safety buffer, so the homeowner maintains their full emergency backup power. Everybody wins. So what does it take to make this real? Exactly 6,000 volunteer homes. Just 6,000 homes equipped with this tech to generate an unassailable 15-megawatt clean energy fortress. That is enough to completely erase the peak-hour utility stress signature of a high-density AI cluster. And the economics behind it? By deploying this 6,000-home community network, the utility instantly erases $22.5 million in avoided generation capital costs. That is a massive chunk of money that would have otherwise been completely wasted on delayed, expensive gas turbines that just sit idle for 95% of the year. Section 4, Google's strategic triple stack. This brings us to the undeniable strategic synergies this pilot presents directly for Google's ecosystem. This isn't just about fixing the grid. It's a massive business accelerator. We call it the strategic triple stack. It's a framework that fundamentally transforms everyday ratepayers into compensated, clean, firm energy partners.
Let's look at the regulatory side first. Pennsylvania has these strict new reset board and grid standards that mandate tech companies prove they aren't passing massive infrastructure costs onto everyday ratepayers. Well, by subsidizing residential edge hardware, Google objectively satisfies these clean, firm energy matching rules. You're turning potential political friction into a massive regulatory advantage, potentially condensing permit timelines from years down to just months.
Commercially, think of this dual-layer defense as the ultimate one-two punch. It perfectly utilizes Renew Home's existing Google Nest infrastructure. You've got the software layer gently lowering grid demand via thousands of Nest thermostats, which is already approved under Historical Act 129 frameworks, while the new hardware layer injects physical power to completely erase the data center load. And onboarding these 6,000 homes is a breeze, thanks to Project Sunroof. Local municipalities can cross-promote this incredible Google tool, completely eliminating the friction of calculating a homeowner's return on investment. You just type in your address, the brilliant 3D aerial modeling does its thing, and boom, it instantly proves the exact financial case for joining the network.
Plus, we're talking direct workforce integration, utilizing local union labor, folks like IBEW Local 5 and Roofers Local 37, for the physical home installations inherently fulfills corporate community benefit requirements. This secures incredibly strong legislative and labor alignments, directly benefiting the very communities hosting this high-tech infrastructure.
So how is it funded? Instead of looking at household subsidies as corporate charity, you view them as strategic infrastructure procurement. By reallocating that avoided capital to provide a $2,500 to $4,000 direct point-of-sale equipment rebate, Google secures localized power instantly. You totally sidestep those massive, multi-year peaker plant backlogs.
Finally, Part 5, a globally scalable model. We're proving this concept in the complex, highly regulated Pennsylvania grid market, sure, but it is far from just a local solution. This 15-megawatt pilot is literally a plug-and-play blueprint. Once it's proven, it's designed to scale geographically, right into Northern Virginia, Ohio, and absolutely any data center market experiencing utility friction anywhere in the world. It's actually wild how perfectly this terrestrial consumer edge dispatch mirrors the distributed solar-powered logic of Google's own Project Suncatcher moonshot. While Suncatcher solves the long-term future by moving compute to space, this virtual power plant protects the grid right here on Earth today. Both brilliantly bypass land use conflicts and those crazy supply chain delays. Ultimately, by empowering millions of self-reliant citizens as active grid participants, we're doing way more than just powering AI. We are building a redundant, highly secure, and resilient national energy fabric that benefits everyone, from the hyperscale developer all the way down to the everyday homeowner. The tech is literally sitting right in front of us. The economics are absolutely undeniable, and the framework is ready to deploy. So the only question left is, are we ready to transform the edge of our grid into our most powerful infrastructure asset today?